Hello, this is Steve at Hydrogen for Health. Today what we're going to do is we're going to measure the H2 content of this new hydrogen water bottle we're carrying. And we're going to go ahead and do that on video so you can see the parts per million of hydrogen that this bottle can infuse into the water. First off, we're going to fill the bottle with water up to the top. For best results, you want to fill this right to this line right here. A little bit of pressure that this bottle produces when it's generating the hydrogen, the less air volume that's left in the bottle, the better, because pressure puts a little bit more hydrogen into the water. So for best results, fill it to about that line. Okay, we're going to go ahead and fill the bottle up. See where I have the water level. I want to replace the cap and firmly tighten it. The blue light indicates that it will put hydrogen into the water for 5 minutes. We'll hit it again, it turns green. That will put hydrogen into the water for 7 minutes. We're going to leave it on the 7-minute setting, and when it's done, we'll measure the hydrogen content with this meter here. This is the ENH1000. This is manufactured and produced by a company in Japan. Very accurate meter. We'll be using that to tell us how much hydrogen is in our water. While the hydrogen is being infused into the water, I'm going to tell you a little bit about the technology that is used in this to put the hydrogen in the water. What this bottle uses is a PEM cell, or proton exchange membrane cell, and on the membrane it has SPE, that's solid polymer electrolyte. Basically all that means is it has a electrode in it, 2 electrodes. One's a positive electrode and one's a negative electrode. And when you apply power across these 2 electrodes, it splits water into hydrogen and oxygen. Hydrogen will collect on the negative plate and oxygen will collect on the positive plate. So what this bottle does is it puts a membrane in between the 2 plates. This is a solid barrier between the positive and negative plate, so that when the reaction happens, it separates the hydrogen and oxygen from each other. So the oxygen will be on one side of the membrane and the hydrogen will be on the other. And what we've done in this bottle is we have the water in contact with the hydrogen side, so that only hydrogen is put into the water. On the other side of the membrane, the oxygen is created and it is exhausted out the bottom of this bottle, right down there. That way you only get hydrogen in the water, no oxygen in the water. So I'm going to tell you why this is important. Right here I have another hydrogen bottle. This is a different type of technology. This one does not have PEM with SPE. This one here is just a straight electrolysis. So what happens in this bottle I don't know if you can see that with the beads there, but there's two plates in the bottom of this, or two electrodes. One of them is positive and one of them is negative. As you can see, they're both on the same side. So, oh, there's a good picture of them. So this has the positive and negative electrode in your water. They're not separated. So what happens is, as hydrogen is being made in this bottle, the hydrogen and oxygen are both being put into the water. And when the oxygen is being put into the water, there's not as much room as there would be if you just had straight oxygen. So the hydrogen content is usually pretty low on these, between 0.4 and 0.6 ppm. So when you split out the oxygen and exhaust it through the bottom of this bottle, you're only putting straight hydrogen into the water. Another reason why this technology, we call it SPE technology. Another reason why this technology is good is on the anode plate, which is your positive plate, different things are created on that plate. If you use water that has any chlorides in it, that's basically any salts. On the positive plate, it'll generate chlorine and a little bit of ozone on that negative plate. So what happens is you get basically tap water, any mineral water, any kind of water other than distilled water is going to have chlorides in it. So that's going to be converted into chlorine and ozone gas, and that's going to be put into your water. That's why this technology is so nice. Your drinking water is completely pure and safe to drink. No chlorine, no ozone in the water at all. Okay, the lights just turned off. Let's go ahead and check the ppm. Alright, right now it's showing just over 1 ppm, or 1035 ppb. Not too bad. I've seen it up at 1.4. If you run it for another 3 minutes, the concentration will go higher. And also, this is a new bottle. As you use your bottle, the concentration will get higher as the membrane gets broken. For example, this is my personal hydrogen bottle that I've been using for the last 8 months, and we'll take a reading on it as soon as the indicator light goes out. And I'll show you what the difference is in a bottle that's a little bit older, a little bit more broken. Okay, indicator light's gone off. Let's take a look at the hydrogen content in this 8-month-old bottle. Let's see, hopefully you can see that. Let me zoom in. As you can see there, it's about 1480 ppb. .48 ppm. One more thing I want to show you on this new bottle we're carrying is it has another different capability that it can do. Let's pour the water out. This bottle has the ability to attach other bottles to it. So we take off the upper there, and inside here it has its threads. There's some threads in there to hook onto any 1 or 2 liter type water bottle. So if you take it, you can screw it right to the top of that. Tip it up. And you can put hydrogen right into the drinking bottle. You can find both of these products on my website. It's www.hydrogenforhealth.com. Hydrogen, the number 4, health.com. If you have any questions, please feel free to email me. You can reach me at steve@greenfuelh2o.com. This concludes this video. Thanks for watching.